stressed, okay? But I'd also be bleeding. Probably, maybe, possibly, somewhere, depending on where the bullet went, okay? But I'm pretty sure there'd be some blood somewhere, okay? Believe it or not, during the first stage, having an increase in these two hormones, we're going to see that they actually play a role in offsetting any type of, bleeding, the sweat production that might be given off, that sort of thing. They're going to play a part in that. So just something that's part of that first stage. Now, the stage of resistance. Well, in the stress response, these stages can go quickly depending upon the stressor. Now, if the stressor is going to be something relatively short-lived, okay, we may or may not use up all of our glycogen, okay? If, however, it's a situation that's kind of turning out to be a little bit prolonged, we're going to see that glycogen reserves could be gone. But remember, the one thing that needs glucose is the brain. The body's going to do what it needs until death to try to supply the brain with glucose. So if our glycogen reserves are gone, we have to go to an alternate form of energy for glucose. All right, so I've used what was in the blood. I've used what was in the stores of the glycogen. What's the next way that my body wants to try to pull to make glucose? Fat stores. Okay, so I'm going to go to the fat stores. And this particular stage is now going to be dominated by cortisol. Love cortisol. Y'all know I don't. So the hypothalamus is now going to get involved because these little receptors that are picking up information, sending information, hypothalamus is going to receive its information and it's going to say, you know what, I need to change this level, okay, for my glucose stores, so I'm going to release my CRH, my corticotropin releasing hormone. That goes on to act on the anterior pituitary and make it secrete ACTH, adrenocorticotropic hormone. This time, we act on the cortex of the adrenal gland. Therefore, you remember the zones that were in the cortex? There were 3 of them. They're going to get activated. We're going to get cortisol. We're going to get those glucocorticoids. Do you remember that from the middle zone? Okay. These go on to act upon the fat stores. So fat will get broken down. Proteins can be broken down. Fatty acids can be used. Amino acids can be used. But because we no longer have glycogen to provide us with glucose, we now have to make it. So the body's going to go into gluconeogenesis. Neo, beginning, with Genesis beginning, neo-new for glucose. So we're going to use products that are not glucose-based or sugar-based and turn it into a sugar. Now, when this takes place, if we get to the point where this the glucose, the cortisol, if we begin to have that fat get broken down, if the stress continues, okay, as that process of the cortisol continuously being used, breaking down other stuff, we're now in our fat stores to break it down to get the glucose. Well, we're going to start affecting other parts of the body. Because with a constant production of cortisol, the constant production of cortisol will actually affect other organs of the body and their uptake of glucose. So if they're going to affect, if this constant production of cortisol affects the other organs to take up glucose, because we're trying to send it to the brain, right? What do you think is going to begin to happen to the other organs and other tissues of the body if they can't get glucose?
They start to shut down?
They can start to shut down. Why?
Well, they also need that glucose.
Why do they need the glucose? It's their energy. It's their form of energy. It's a form of their metabolism, right? So we have now affected that cell's metabolism, affecting its homeostasis. We're now pulling from areas of the body that are going to eventually get depleted, okay, to make the glucose. And in doing so, we're going to begin to affect our health. So if the stressor becomes a long-term stressor, we're going to now begin to affect, for example, the immune system. Because guess what? That's tissue. It needs energy. It needs nutrients. If we affect it, we're going to affect the ability to produce the cells we need. We're going to affect the lymph nodes. Okay? We're going to affect other tissues of the body. So if we continue to have the stress, all right, we're going to begin to see we get more susceptible to infections, viruses, all this stuff that might be trying to invade us. Now, the other thing that happens that's kind of interesting with a long-term release of cortisol, it begins to affect sex hormones. It's a reason that there might be infertility problems for some people. Like if one of the other has let's say a high stress job, okay? Well, that's a prolonged stress that you get very little relief from, okay? So eventually that's going to start taking over and affect for example, the production of either egg or sperm.
Could smoking like marijuana affect that too?
I would think that the only way that could begin to be a problem is the constant use of marijuana. And then what that begins to do, it doesn't matter what you smoke, it affects the lung tissue. If you affect the lung tissue, you're going to affect the ability of oxygenation throughout the body. So therefore you're going to affect the cells of the body having their ability to function. So I would think that a continuous prolonged usage, yes, could affect those tissues. Yeah. Now the final stage that's going to happen is what's termed exhaustion. We can have those fat stores. They're going to get their supplies, but eventually that's going to break down. There's not going to be any more of the fat to pull from these fat stores. Once those fat stores are gone, because we're only pulling from the fat stores because we've already used what was in the blood, we have used what was stored in the liver and the muscle. We've now used what's been stored in the fat cells, Now, we have only one other choice to pull from to make glucose. And where is it gonna pull from? Our muscle cells, okay? The proteins. That is not the place that we want to make glucose from. So by breaking down the proteins, the first place that it's going to pull from is skeletal muscle. So therefore you begin to see that the muscles waste away. And don't forget, once that happens, that doesn't come back, okay? You can't build that back up. We begin to see that maintaining glucose most likely is going to be an issue. The adrenal cortex starts slowing down. We don't get the those hormones that we should be getting. What this will do is it's going to begin to affect this water retention. Now what will happen is when that adrenal gland gets affected, that begins to affect sodium and potassium. Hopefully, that's two things y'all have not forgotten. What do we think of when we hear sodium and potassium?
Okay.
We think of the pumps, right? Where we need to maintain the levels of sodium inside and outside, potassium inside and outside the cell. Is that correct? Mm-hmm. Now, this can lead to elimination of potassium. That means eliminate potassium from the body as a whole, okay? And at the same time, it's going to try to conserve sodium. We're going to also affect H pluses. What does H plus play a role in?
The positive and negative charge in the cell.
The what?
Water reduction.
H pluses. Hmm?
Eliminating the acids.
pH. pH is the power of the hydrogen ion. pH of the body needs to be maintained very closely. Okay? Just a small increase or decrease can lead to serious health effects. So what we're going to see is this leads to a possible condition called hypokalemia. Hypokalemia is where we're going to have the low potassium that's in the blood, and alkalosis is a high pH. This leads to death. I know. Because the result of this is nerve and muscle function just gets totally affected. We have more than one type of muscle. Is that correct?
Mm-hmm.
We've got skeletal,
Smooth.
smooth, and cardiac. And did not all three of them depend on sodium, potassium? Okay? There you go. And it's gonna kill you.
So, when would this happen? Like, really a high-stress job will do this?
Now, when I was going through this, it made me think about the stress that I suffered when I lost my son. Okay? Because that was, first of all, a traumatic incident. Okay? And